Good day, fans. Today we have the following integration problem. Integral from 0 to infinity, the square root of x all over 1 plus x raised to power 3 dx. Okay? If you have not subscribed to this channel, please subscribe, share our videos and comment. Wow. Looking at this, I think this is the beta function we all know about, okay? Which I used in our previous video. But before that, we're going to make substitution because the beta function looks like this. So we have it like this: the beta of mn is equal to integral from 0 to infinity. So I think we have the same thing up there. So like this, because this is x raised to 1 over 3. And down here, the power of x here is 3. But here the power of x is 1. So first substitution here is to let s cube to be equal to another different variable. Okay, so I will say let s raised to power 3 equals y. So taking cube root of both sides, x is equal to the cube root of y. So from here, differentiating both sides, we get dx is equal to 1 over 3 times x raised to a negative 2 third times, that is 1 over 3 times y raised to a negative 2 third dy. Okay, so now we have integral, the limit remains the same, integral from 0 to infinity. Why I say the limit remains the same, here we have y is equal to, when s is 0, we get 0 cube is 0, infinity cube is infinity. So here cube root of, here we have x equal to cube root of y, but here we have square root of x. So we are going to have square root of, instead of x, so we write in bracket the cube root of y, okay, all over, down here we have 1 plus y, then our dx is equal to 1 over 3 y raised by negative 2 third dy. Now we can write as follows: 1 over 3 integral from 0 to infinity. Remember there we have y, cube root of y is y raised to 1 over 3, and the square root is also 1 all over 2, like this. So all over 1 plus y, then times y raised by negative 2 over 3 dy. Wow, this makes sense. So here we have 1 over 3 integral from 0 to infinity. Up there we have y, 1 over 3 times 1 over 2 here, so we get 1 over 6 times y raised by negative 2 over 3. And down here we have 1 plus y dy. So here we have this equal to 1 over 3 integral from 0 to infinity. According to the law of indices, 1 over 6 plus that negative 2 third, that is minus 2 over 3, here over 1 plus y dy. So here now we have this equal to 1 over 3 integral from 0 to infinity. If you subtract this properly, we get y raised to 1 over 2 over 1 plus y dy, and this is equal to 1 over 3 integral from 0 to infinity y raised to, we're going to rewrite 1 over 2 as follows. So we're going to write as 3 all over 2. So we're going to write as 3 all over 2. I'm so sorry, here we have negative 1 all over 2. Okay, so we're going to write this negative 1 over 2 as 1 over 2 minus 1. Okay, so here we have 1 plus y. So remember the property of the beta function, so we can write 1 over 2 plus 1 all over 2 here. So we can write 1 over 2 plus 1 over 2 here, because the power of this 1 plus x in this bracket here is just 1. Then we have here the y. Okay, so we can take our function now. So we have this is equal to 1 over 3 the beta of 1 over 2 and 1 over 2, and according to the relationship between the gamma function and the beta function, so we have here 1 over 3 times the gamma of 1 over 2 times the gamma of 1 over 2 all over, the gamma of 1 over 2 plus 1 over 2. So from here we get this equal to 1 over 3 times gamma of 1 over 2. We all know this is equal to square root of pi times the gamma of 1 over 2 square root of pi all over, 1 over 2 plus 1 over 2 here in this bracket. So we have gamma of 1, and this is equal to 0 factorial. 0 factorial is equal to 1, so we get here over 1. So we finally get square root of pi times square root of pi is equal to pi all over 3 times 1 is 3, and this is the final answer to our problem. Thank you for viewing. Please subscribe to my channel, share and comment. Thank you.